Okay, friends, welcome again to 8th module of this course. We will be continuing with whatever we have started yesterday in the previous module. What we looked at was analog and digital signaling. We looked at the square signals, and then we have seen that square signal is made up of multiple harmonics, and we have also seen the Nyquist and Shannon limits and how one use them to decide the amount of voltage levels. That is what we have seen. We will continuing from that in this particular module. We will be discussing about different ways to use EM waves for data transmission. We have already seen this signaling is, and this is something we have already looked at. So, let me go ahead. Okay, now, let us go further. Let us try to understand one more critical thing, which is called periodic and aperiodic waves. A periodic wave is something which repeats itself after a while. You can see that the same shape of signal is being repeated in every cycle. Here you can see that the shape is not preserved, and that is why these are called aperiodic signals and these are called periodic signals. Data communication usually is about periodic signals, but anyway, we will not talk much about that now onwards. Now, here frequency, I mentioned frequency, I just said that frequency is number of oscillations per second, but now you can see that here you can see that this particular case number of oscillations are 5 in 1 second, the frequency is 5, number of oscillation here are 10. So, the frequency is 10, the period is 1 upon frequency, the period is 1 upon 5 here, 1 upon 10 here. Okay. The phase of a signal is the other property. Now, what we are doing, in fact, let me tell you, we are in the previous module we looked at digital signals. In this module we are looking at analog signals. Okay. So, here this is the other property of analog signal. The first property is frequency, that we have already seen. The second frequency, this thing is called phase. Now, try to understand what is phase. In this case, okay, this is my wave. Now, at this point of time, this is the time. At this point of time, what is the movement of wave? You can see that it is this. And what is the propagation direction? Propagation direction is this. What you will have to do is to find out the angle of the propagation direction of propagation with the angle that the wave is making at this point of time. Now, angle is 90 degrees. So, what you can do is, what I can say is at this point of time, the phase of a wave is 90, it makes a 90 degree angle with the line of propagation. Okay. So, in this case you can see that it is this. So, it is 90, 180 and 270. Okay. So, it is 270, that is why this is called 270, this is the first one. What is this at this point of time? It is the same direction as the propagation. So, that is called 0. Okay. In this case, I just talked about this case, this is exactly perpendicular to the line of propagation, that is why it is called 90 degree. So, the phase is the angle that the wave makes as a particular time. Okay. So, at this point of time the phase of the wave is 270, at this point of time the phase of the wave is 0, at this point of time the phase of the wave is 90 degree. Amplitude we have already looked at, amplitude is the height of the wave, okay, whatever it is. 5 volt means it talks about this is the distance. Okay. So, that is amplitude. And wave changes its phase continuously. Okay. So, please understand here at this point of time the angle that it creates with the line of propagation is this, at this point of time it is this, okay, this line. So, it continuously changes its phase or the angle. Okay. Now, what you are supposed to do once if you want to use analog signal for data transmission, you need to make sure that your zeros and ones are represented in some form. Okay. So, every wave has 3 properties, amplitude, frequency and phase. You need to change them to make sure the other party understands that now you switch over from 0 to 1 or 1 to from 1 to 0. So, that process is known as modulation, and we will soon see how it is done. Okay. Some property of the analog wave, frequency, amplitude and phase. Okay. This thing. Okay. A modem that you probably have seen long back, it was, now people do not use modems today. So, when you use modem, what you do is you just connect your computer to modem and that modem connects to the telephone line. If you use an old fashioned modem, when you use that modem, you will not be able to talk, because once you connect your telephone line with the modem, the very line is used for data transmission, you will not be able to use that line. Okay. Currently, we have a different case. The current telephone lines are ADSL lines, which has different thing, and we will be learning about that, how they provide that. You have a better networking experience, as well as you can still have voice and they do not interfere with each other, but modem was like that. Okay. But modem is an example of a modulation case. Okay. Let us look at these 3 types of modulation. If I want to use an amplitude modulation for sending zeros and ones, I can use 2 different amplitudes. Now, you can see that this amplitude of this wave is much shorter than this. So, what you can do is, what you can say that a shorter wave means 0, a bigger wave means 1. Okay. So, this is basically 0 1 0 1 0 1 0 1, I am and 0 1 0 1 0 1 1 1, because I am looking at the amplitude and decide whether the sender is sending zeros and ones. Okay. So, the amplitude decides that thing, that once you do that, is called amplitude modulation. But the problem with amplitude modulation is that whenever there is noise, an external noise comes to the device, it will always affect amplitude. What does that mean? If this is my original wave and there is a noise added to it, what I get is something like this. My original wave is changed. So, many a times your 5 amplitude becomes 10, and what is the consequence? When the amplitude which used to be 5 becomes 10, 0 becomes 1 and you get an error. So, amplitude modulation has this problem. Okay. Whenever there is a noise, it is very likely that will convert a 0 into 1 or 1 into 0, that is the problem. So, amplitude modulation is not used as alone, okay, it is used in conjunction with something else. Okay. We have already looked at repeater in earlier, okay, and the amplifier, when you use it, amplifies the signal like this. Remember, repeater was used for digital signals, which can reshape the signal. So, we can get the signal back. Here it is not possible, the amplification process also increases the noise. If you have ever used any amplifier yourself, you know, because amplifier also amplifies the noise in the transmission. Why it cannot eliminate noise and why digital signal can eliminate noise, we will also see later. Okay. The second type of modulation is called frequency modulation. I use different frequencies for zeros and ones. You can see that I use more higher frequency wave for 0 and lower frequency for 1. I can use any, in fact. Okay. I can use any type of frequency that I want. So, I am using one frequency for 0, one frequency for 1. Okay. So, I am able to send this value using different frequencies. So, if I have the receiver higher frequency, you will understand it to be 0, while receiver will receive low frequency data, will understand it to be 1. So, this is how it understands. Phase modulation is a little more interesting. Okay. If I have 0, the wave at this point of time is moving downwards. Okay. So, I consider one phase. At this point of time, okay, now this one thing is critical. What I am talking about is the beginning of a specific time slot. Let us call it the origin. Okay, this is, let us call this origin. So, at this point of time, the phase is calculated, because every minute the phase of the wave is changing. So, we will have to pick up one specific instance of time. So, it is always picked up at origin. So, in a given time slot, suppose this is my time slot, I will start always with a typical this thing. So, at this point of time, what is the angle of this wave, and that decides the value. The next slides throw a little more light on it. Okay. I have decided that I will use two phases, okay, 0 and 180 degree, or sorry 90 and 270. So, if my wave is going downwards, in the beginning it will be 0, my wave is going upwards, it will be 1. So, 0 will always begin like this, 1 will begin like this, and again it is 0, you can see that the wave has gone here and then gone back. Okay. So, this is how phase modulation can also work. And phase modulation, however complex it looks like, is the best modulation. Why? Because it is not affected by noise. The problem with amplitude modulation is that if I use an amplitude, if I use two different amplitudes, for example, this is 0 and this is 1. Okay. I have kept some distance between 0 and 1. If I expect lot of noise, then it is quite possible that 0 is converted to 1. So, what I am supposed to do, I will have to keep bigger amplitude. I can always do it. I can say I use 5 volt for 0 and 10 volt or 20 volt for 1. So, in that case the noise will not be able to increase to that level, but the problem is that I am using a 20 volt case, my battery will be drained much faster, because it will use more power, because amplitude represents power. I need more power to generate a bigger wave, and that is not in favor. If my phone starts using it, a higher this thing, it will drain battery in half a day if it is taking 1 day. So, that no user would love. So, that is the problem with amplitude modulation, that thing will not affect, okay. Noise will not affect the phase or the angle of the wave, and that is the reason why phase modulation is not affected, and you can use a lesser smaller amplitude there. So, that is the power of phase modulation, and that is what I am trying to convey here. Okay. So, it allows the device to operate at low power, and saving the power, obviously the battery runs longer, and that is what people are asking for. The modulation is used in practice. Okay. Here is one example. Okay. You can see that again, when you draw a signal like this, and when you have something like this, you may not be able to relate directly, but if you draw a circle, you will be able to understand. Okay. What is the angle? This is 45. What is the angle here? Okay. You can see that there are 4 angles. These are 4 phases, phase 1 and phase 2. And what is the amplitude value? The distance, only 1. I do not change the amplitude, I only use 4 phases. So, when I use 4 phases, okay, it is very like signal levels. When I use 4 phases, I use 4 different points in something called constellation pattern, this is called constellation diagram. What is the advantage? When I use 4 of them, I will be able to send 2 bits per signal. I can even use more. You can see that I am using 3 different amplitudes, 4 different amplitudes. This is and this distance is the amplitude. Amplitude 1, amplitude 2, which is middle, and this is amplitude 2 is which is highest, and 3 phases in each this thing. Okay. So, total 3 here, 3 here, 3 here, 3 here. Okay. 3 into 4, 12 different phases, angles. For example, this is the lowest angle, this is a higher angle, this is a higher angle, even higher angle, and so on. Okay. So, I have 12 different phases and 3 different amplitudes. Okay. 12 into 3 actually gives me a lot of value, but I am not using all amplitudes. See, I am not using higher and lower amplitude in this case. I am not using the middle amplitude here. I am not again using 2 amplitudes here. I am avoiding them because remember I have told you, if you keep amplitudes nearby, a small increase in noise will create a problem. Okay. But anyway, this is called QAM, amplitude quadrature amplitude modulation, which includes both phase as well as amplitude modulation. You may be surprised why I am not using frequency modulation, why real world is not using frequency modulation, just for the same reason that a frequency modulation demands me to use two frequencies. So, if I have 10 MB for example, I will only get effectively 5 MB, because I will have to divide that thing into two parts. I will get 5 MB for 0 and 5 MB for 1. Okay. So, I can't use both parts. So, I need two frequencies for sending something. So, that is not usually preferred. Okay. Now, digital signaling I have already talked about a bit, okay. And I do not want to repeat that, but you can see that each level indicates a typical set of bits, okay, a unique digital value. Okay. And two levels we have talked about, and we have also talked about multiple levels earlier. The duration is very important value in digital signaling. Suppose if I am sending a signal, something like this. Now, assume that this is plus 5, this is 1, minus 5 is 0. So, this is 1, 0, 0, 1, 1, that is what I am sending. Okay. Now, this duration is this duration, which is very critical, because if this duration is different in sender and receiver, there is a possibility of chaos. Now, what is the problem? Problem is described here. This is microsecond. Okay. So, 1.1 microsecond is 10 raised to minus 7 second. Okay. So, in 1 second you can have actually 10 raised to 7 seconds can be sent. Okay. So, the huge speed currently. The clocks are very good, in fact, the current clocks are very good. The problem is that the amount of data that is being sent is very fast. So, it is quite possible that the sender's clock and receiver's clock are drifted a bit, and you have that problem. So, when there is a drift, what is the problem? Let us see. Okay. In digital signal, we will soon see it. Okay. Again, that is what I have told you earlier also, that if there is a noise, the problem of noise is this. Even in digital signaling, the problem with noise do exist. Okay. If this is my plus 5 volt, if I have a noise, will increase to 7, plus 7. So, noise is possible. If I am using 5 and 9, then 7 is a problem to me, because I do not really know whether 7, which when I receive 7, whether it was 5 or it was 9, that could be a problem. Okay. So, error is possible. So, we will need to keep symbols sufficiently apart, this thing, so that they do not convert. Suppose if I have 5 and 10 and I will have a noise of 5 volt, 5 volt will be converted into 10. So, it will convert one valid value into the other. Okay. And but then we will have to keep this voltage level as less as possible to make sure that the device runs less battery. Okay. Anyway, here are two this thing. Baud rate is a symbol rate, number of symbols that you send or number of signals that you send across, and bit rate is number of bits that you send across. We have already seen that usually we have more bits than the baud. So, the baud rate is usually higher than the bit rate. Okay. Sorry, the bit rate is usually higher than the baud rate, but in one typical case that we will see later, the Manchester encoding, the bit rate is lower than the baud rate. You may be surprised why it is so. We will soon understand what is the need. Let us try to understand the difference between analog and digital signaling a bit. Digital signal use square waveforms, while analog signals use curved waveforms. That I have already discussed about. And the power of this thing is that I have this signal. If I use plus 5 and minus 5, for example, this is 1 is plus 5, this is 0, minus 5 is 0. If I have some change, if this signal changes to this or this signal changes to this, I can still figure out, because I have discrete values, I can still figure out that is 0 and this is 1. And I can correct the signal even if the signal does not remain square. For example, if I have something like this, I can still understand that is basic, most probably it is like this. So, I can correct that signal. A repeater does exactly that, it corrects the signal, reshapes the signal, which is not possible in the case of analog. So, that is power, that is good thing about the digital signaling. We can restore this signal I have talked about. But the problem with square signal is that they demand infinite bandwidth. When we looked at that harmonics in the previous module, we have seen that this is a very difficult thing to do, because if you want a square signal to be sent intact to the other end, what you need is you need infinite bandwidth. Then and then all harmonics will pass through and you will get the square signal intact, and no media in the world can provide infinite bandwidth. But again there is an advantage, because higher order harmonics play a very little role in the shape of the signal. First few harmonics, they have higher amplitude, so they play a major role in deciding the shape of the signal that the receiver receives, and that is the reason why even if some harmonics are lost, receivers will be able to pick up exactly what is being sent. Okay. So, some tolerance anyway needed, and most of the receivers are capable to do it. Okay. As I said, it is easier to correct, catch and eliminate errors in digital communication because of this thing, but it is comparatively harder in analog signals, and most of the cases is almost impossible for us to remove errors. That is the reason why even analog data is being sent on digital form. For example, our voice call, whenever we are calling somebody from our place to the first exchange will go as analog. Okay. The voice is basically a analog waveform. It is converted to digital form using something called pulse chord modulation method, okay, and converted into a 64 kbps digital signal. Why? Because you can catch errors, and if you have ever talked to somebody in US 10-15 years back, you know you will have to literally shout to make the other person heard, because it is analog, it introduces lot of errors. So, you will have to use very huge signal strength, you will have to speak loud. That is not happening today. The reason is digital signaling is used in that case. So, even for analog transmission, people use digital signaling just because of this property. Okay. Actual and distorted signal, I just drawn this signal on my own, but the signals are distorted, but still you can see that if you are using distorted this thing, you know exactly what you are sending. It is 0 1 1 0 1 1, you can easily get that thing. Okay. So, in most cases distorted signals will get okay, a digital signal can always be corrected, and that is something which is really good. Okay. Now, we will talk about analog and digital transmission, the data itself. Now, let us understand signaling is type of signal that you are sending across, but that signal represents some data, okay, and that data is transmission. That is what we are trying to talk about. And when we talk over phone, we are speaking something, what we generate is an analog wave. So, the data is analog, but if I am using a mobile phone, it is using something called GSM. If I am using a GSM mobile phone, it is using analog signaling. So, my analog wave is converted to some other analog wave and transmitted. When I am calling over landline, as I said, the very analog wave that I generate at the exchange is converted to PCM and converted into digital form. So, analog data, but then the signaling is digital. Okay. Other way around is also possible. I can use computer to generate a file which is basically 0 and 1, and I am using an Ethernet card to send. Ethernet card is using digital signaling, and that is the reason it is digital data and digital signaling case. In fact, when I use an old fashioned modem, it is exactly the opposite. I am sending a file which is basically 0 and 1, the data is 0 and 1, but what I am sending over in form of a voice. So, those zeros and ones are converted into voice forms, the analog form, and sent across. If you have ever been to calling a modem from somewhere, you probably have heard strange noises. That is basically a digital information welcome message that you do, and if you use a real fax machine on this side. But if you call that fax machine, it will send you a digital information in form of a waveform, which is not human voice. So, you receive whistling kind of sounds and all that from the other end. So, that is the problem. Anyway, so here are some examples. Human voice is an analog data. Skype and FaceTime are example of digital signaling for voice data. Okay. So, your voice is converted into data packets and then sent across. Landline phone is also an example which I talked about. Most of the analog data is transmitted in digital form today, just because it is better and more, it is easier to handle errors. Okay. But then you may be surprised, when I say that one analog signal, I speak something, it is converted to some other analog signal. The GSM is using some other frequency than my voice frequency. My landline phone in the beginning also does the same thing. When I speak over my phone, I usually use 30 hertz to 3300 hertz. No human being can talk above that range. So, my voice is confined to that range, but whenever it is sending across, it will increase that or decrease that, depends actually. Not in decrease will not decrease, will always increase it, will that will happen. Will not send the voice as it is, will increase that and send. There are reasons for it. In case of digital also, I am using zeros and ones. You may assume that my file with 0 will be sent as 0 and 1 is 1, it will not send it that way, will convert that into some other form. Okay. Again square digital form, one digital form into other digital form. You may be surprised why it is so, why it is needed to be converted from one digital form into the other. There is a need, because every communication media, as I said, favors some frequencies and do not favor some. Not only that, there are other issues. Okay, we will be talking about other issues later, but then some signals will have some problem. So, if you just send file as it is, might not be able to reach to the other end because of these additional issues. So, what you are supposed to do is to convert this original digital form into new form, which can pass through that media without much of a trouble. Okay. And that process is known as coding. Coding requires you to convert one digital form into the other to make sure the receiver receives that correctly. One particular example is known as 8B/10B, which is used in Ethernet today. And when you use Ethernet, connect Ethernet with fiber optic lines, 8B/10B is used. Now, 8B/10B does what? It says that I am generating 8 bits from my computer. It is converted to 10 bit and sent across on that wire. It is wasteful, obviously wasteful, but then there is a reason. When it is converted to 10B, we will avoid some patterns which can be problematic during the transmission. So, when I am converting 8 bit into a 10 bit, that I have a lot of choices available to me. In fact, every byte 8 bit can have 4 different possible forms. Okay. When I have 2 additional bits, I have 4 different forms. 00 is 1, 01 is 2, 10 is 3 and 11 is 4. So, I can have 4 different, I can send the very byte with 4 different ways, and I will choose the way which reduces the amount of error. Okay. So, that is the power of this coding, and that is the need for this coding. So, whenever I say that digital data, digital transmission, analog data, analog transmission, in most cases even that changes. Okay. There is one more thing, I will give you an analog this thing. Analog communication also requires something like this. As I said, human speaks from 30 hertz to 3300 hertz. When you receive a radio, the radio is 98.9 or whatever, 95.0 and all that. That is basically a frequency that radio transmits. So, your voice is converted to that frequency, and when you listen, your radio, your mobile radio receives that information on that frequency, converts back to 30 to 3300. So, you can actually listen it. Okay. So, this transmission, this change is very necessary and required. That is the reason why you need all these coding mechanisms. Okay. So, coding mechanism basically does this: pick up a bit pattern provided by user, convert that into a form which is capable of sustaining most transmission related errors. That is the reason why we do it. With that note, we conclude this module. What have we seen in this module? We started with modulation process. We looked at 3 different types of modulation: amplitude modulation, which varies amplitude of a signal for representing zeros and ones; frequency modulation, where you vary frequency; and phase modulation varies the angle of the wave at the beginning of the time slot to represent zeros and ones. Okay. So, these 3 types of modulations are used for sending analog waves, for sending digital data. Okay. It is also possible both, and that is digital and analog signaling, both of them can be used to send any analog or digital data. It is possible to send any type of data with any type of signaling, but digital signaling is a little better because it can manage errors. Analog signaling is not all that good because it cannot manage errors. Okay. So, in the most of the cases we use analog digital signaling, and even when we use the same signaling as the data, we need to modify it. That is called coding, and we have seen why we need coding.